This is Professor Charlie Evans, and this morning I'm talking about the scientific revolution and the Enlightenment. And what you're looking at on your screen right now is an apple. It's actually a pretty large apple. I couldn't even get it entirely on the screen. And some of you might guess the connection between this apple and the scientific revolution. The connection, of course, is that by tradition, Isaac Newton, while sitting in the garden after dinner, observed an apple falling from a tree and began to wonder why an apple always falls from a tree. Why does an object always fall perpendicular to the earth, straight down? And those questions in the long run led to Isaac Newton formulating his idea of the law of gravity. What's slightly more amazing about the story is that historical evidence pretty much confirms that Newton actually did see an apple drop and that it actually was an inspiration for his work that led to his law of gravity. Look, the scientific revolution had been going on since the 16th century as scientists observed the world around them, observed the skies, observed the solar system, and began to formulate mathematical laws that explained the world, the natural world. Those natural laws could take the form of the law of gravity. If I remember, it's mass 1 times mass 2 proportional to the square of the distance or something like that. There's a law that explains the gravitational force between two objects. There's a law that explains acceleration of an object. Force equals mass times acceleration. There's a law, I don't know. There's other laws, there's scientific laws. That's the whole point of the scientific revolution, was discovery of mathematical relationships in nature that explained the world around it. And this ongoing scientific revolution, which began in the 16th century with observations of the solar system and the heavens, continues to this day. There's different phases of it. You've all heard of Einstein's theory of energy from the early 20th century. There's transistor technology. I mean, this is a continual legacy of scientific discovery and innovation that goes back in the Western world to the 16th century. Now, the Enlightenment was similar in some respects to the scientific revolution. What the Enlightenment philosophers, thinkers sought to do was explain the human world and human behavior with laws the way that scientists were trying to explain the natural world. And the laws weren't really in mathematical form as the scientists were using, but they were still laws that explained human behavior. For example, John Locke postulates that there are something called natural rights that everyone is born with. That's a natural law. That's something that is universal, that everyone has these rights, is entitled to enjoyment of these rights. That's what the philosophers sought to do, is explain the human world in these kind of terms that could allow enlightened government figures, enlightened people to improve the world. Because once you understood the basic mechanism of human society and human interaction and human behavior, then you could try and get rid of the bad parts of human society and improve society. You could get rid of poverty, you could get rid of war. In some ways, the Enlightenment were very utopian, very kind of idealistic thinkers. That would change In time, it would change largely as a result of the French Revolutionary Wars of the late 18th century. But really, the Enlightenment sought to extend the scientific revolution into the human world. And when you study the scientific revolution, you study all these great thinkers. You study Newton, Kepler, Copernicus. When you study the Enlightenment, you study all the great 18th century thinkers, Rousseau, Montesquieu, Voltaire, Diderot, all of which had an enormous impact on the intellectual developments in the Western world, which then transferred to the entire world in succeeding decades. Okay, thank you.